You're about to throw away a piece of metal that could quietly power a light bulb inside your own house, and you don't even know it. Somewhere in your garage, in an old dead fan that stopped spinning years ago, there's a small motor sitting inside, collecting dust, waiting to be thrown into the trash. Most people look at that motor and see junk. But what if I told you that same motor, the one you were about to sell for scrap metal, still has enough hidden power inside it to light up a room, charge a phone, or run a small device without ever touching a wall socket again? Stick with me for the next few minutes, because by the end of this video, you will never look at an old fan the same way again. And before we go further, if you like learning things that actually save you money, hit that subscribe button right now, because what comes next in this video is something almost nobody talks about. Let's start with something simple. Every year, millions of old ceiling fans and table fans get thrown out. Not because they are useless, but because one small part breaks, usually the blades or the switch, or the outer casing cracks after years of spinning. The moment that happens, most people don't even think twice. They pull the whole fan apart, throw the plastic in one pile, the metal frame in another, and forget about the heart of the machine sitting right there in the middle. That heart is the motor. And here is the part almost nobody stops to think about. That motor was never really dead. It was just disconnected from its job. The coils inside it, the copper windings, the magnets, none of that stopped working just because the fan blades cracked. The motor is still, technically, a small generator waiting to be woken up. Now, I want to be honest with you here, because there's a lot of misleading content online about this exact topic. Some videos show old motors and claim they are something they are not: alternators, special generators, magical free energy devices. That is not what this is. Let's be clear from the very beginning. What we are talking about is a simple electric fan motor. Nothing more, nothing less. It is not a car alternator. It is not some rare industrial part. It is the same ordinary motor sitting inside the ceiling fan above your head right now, and that is exactly what makes this so interesting. Because if something this common, this overlooked, can be turned into a small working power source, then almost anyone watching this video already has access to it, sitting in their attic or basement right now. Here is how the basic idea works, in the simplest way possible. A motor and a generator are, in many ways, two sides of the same coin. When you send electricity into a motor, the coils inside create a magnetic field, and that field pushes against magnets, which makes the shaft spin. That is how your fan blades used to move. But reverse the process. Instead of sending electricity in, if you spin that same shaft using some outside force, wind, water, your own hand, a bicycle pedal, anything, the coils inside start doing the opposite job. They start producing electricity instead of consuming it. The same copper wire, the same magnets, just working backward. This is not some rare secret hidden from the public. Engineers have known this basic principle for over 100 years. What is surprising is how few people realize the motor sitting in their trash pile is capable of doing this right now, with almost no modification. But here is where most videos on this topic stop, and where people get frustrated because they show you the concept, but they never explain the details that actually matter. What kind of wire is inside these motors? How many times is it wound around the core? Whether copper or aluminum wire makes a real difference in performance. These are not small details. They are the entire difference between a project that works and one that just sits there doing nothing. And that is exactly why we are not going to rush through this. We are going to slow down and actually look at what is happening inside that motor, piece by piece, so that by the end of this video you understand not just the idea, but the real mechanics behind it. Think about the last time you saw an old fan sitting on the curb, waiting for garbage pickup. Somebody spent money buying that fan years ago. It served its purpose. And then, the moment it stopped spinning, its entire value dropped to zero in most people's eyes. But value is a strange thing. It depends entirely on what you know. To someone who does not understand what is inside that motor, it is just dead weight, a few dollars at the scrapyard if they're lucky. But to someone who understands the copper winding inside, the magnetic core, the way current is generated by simple rotation, that same piece of trash becomes something else entirely. It becomes a small power source with almost no cost attached to it, because you already paid for it years ago when you bought the fan in the first place. This is actually a pattern you'll notice throughout history and throughout economics in general. The things people throw away the fastest are often the things holding the most overlooked value, simply because nobody bothered to understand what they were looking at. Old motors are a perfect small-scale example of this. They're everywhere. They're free, or nearly free. And yet almost nobody stops to ask what else this piece of equipment might still be capable of doing once its original job is finished. Now, I know some of you watching this are already skeptical, and honestly, that is the right instinct to have. The internet is full of videos that promise free energy and unlimited power from random household objects, and most of it does not hold up under any real scrutiny. So let's set expectations properly right now before we go any further. This is not a magic free energy machine. This will not power your entire house. What we are talking about is a small-scale generator, capable of producing a modest but real amount of electricity, enough to light a small bulb, charge a low-power device, or run a small circuit, depending on how fast the shaft spins and how the motor is wired. That's it. That's the honest scope of what we're discussing. No exaggeration, no fantasy claims, just a genuinely interesting use for something you were about to throw away. So here's where we're headed next. We're going to open this motor up, mentally and visually, and look at exactly what's inside it, the copper coils, the magnet, the way it's structured, and why the number of turns in that wire actually determines how much power you can pull out of it. Because understanding that one detail is the difference between someone who watches a video like this and forgets about it by tomorrow, and someone who actually understands enough to try it themselves. Let's open this motor up and actually look at what makes it tick, because this is where the real understanding begins. Inside every small electric fan motor, there are three main things you need to know about. First, there's the stator, the stationary part, which usually holds the copper windings. Second, there's the rotor, the part that spins, often connected to a shaft. And third, there are the magnets, sometimes built into the rotor, sometimes surrounding it, depending on the design of the motor. These three pieces working together are the entire secret. Nothing exotic, nothing rare. Just copper, magnets, and a shaft that spins freely once you remove the fan blades and the outer casing. Now here's something most people never think about when they look at a motor like this. The copper wire wrapped around the stator isn't just randomly coiled. It's wound in a very specific pattern, and the number of times it wraps around, what engineers call turns, directly affects how much voltage the motor can produce when you spin it. More turns generally means more voltage at a given speed, but thinner wire, which allows for more turns in the same space, also means less current it can handle before overheating. This is the actual trade-off hiding inside every one of these motors, and it's exactly the kind of detail that gets skipped over in most videos, leaving people confused about why the results don't match what they expected. And this brings us to a question a lot of people ask, and rightly so. Does it matter if the wire inside is copper or aluminum? The honest answer is yes, it matters quite a bit. Copper has lower electrical resistance than aluminum, which means for the same size of wire, copper allows electricity to flow more efficiently with less energy lost as heat. Most fan motors, especially older ones, tend to use copper windings, because copper was the standard choice for smaller motors for decades. Aluminum windings became more common later in certain cheaper, mass-produced products, mainly because aluminum is lighter and less expensive. If you're testing an old motor and trying to figure out what you're working with, copper wire will typically look a bit more reddish-orange and feel a bit heavier for its size, while aluminum will often appear lighter in color and weight. This one detail alone can completely change how well your setup performs, which is why it's not some minor footnote. It's actually central to understanding what you have in your hands. Now let's talk about turns, because this is the second piece of the puzzle that most people never get a clear answer on. The number of turns in the coil isn't some fixed, universal number. It depends entirely on what the motor was originally designed to do. A small fan motor designed to run on standard household voltage will have windings calculated for that specific voltage and speed. This means you can't just guess a number and expect it to work perfectly. The real number depends on the specific motor you're holding, its size, its original power rating, and its intended rotational speed. This is exactly why, when people ask, how many turns do I need? There's no single answer that fits every motor. It's not a secret being withheld, it's simply a calculation that depends on your specific goal, how much voltage you want, and how fast you're able to spin the shaft. This might sound complicated, but here's the part that keeps this whole idea exciting rather than frustrating. You don't need to be an electrical engineer to understand the basic relationship. The faster you spin the shaft, the more voltage you generate. The more turns of wire in the coil, generally, the more voltage you generate at a given speed, but at the cost of how much current it can safely carry. It's a balance, not a mystery. And once you understand that balance, you start looking at every old, broken fan sitting in a garage or a junk pile completely differently. It's no longer just dead metal and plastic. It's a small, already built generator, just waiting for someone who understands the basic principle to put it to use again. Let's step back for a moment, because there's a bigger picture here that connects to something much larger than just fan motors. This is really a story about how value gets hidden in plain sight. Think about how many things around your house follow this same pattern. Old phone chargers with usable transformers inside. Broken printers with functional motors and gears. Dead car parts with copper wiring, worth more than people realize. In almost every case, the object itself gets thrown away as a whole, useless unit, when in reality, only one small part failed, while the rest of it, especially anything involving copper wire and magnets, often still works perfectly fine. Fan motors are simply one of the clearest, easiest examples of this pattern, because they're common, they're simple to open up, and the science behind them is easy enough for almost anyone to understand once it's explained clearly. Now, some of you might be wondering, does this actually produce useful electricity, or is this more of a fun experiment with no real value? This is a fair question, and the honest answer is, it depends on your expectations. As we already covered, this isn't going to power your refrigerator or run your air conditioning, but small-scale power generation has real, practical uses. Charging small batteries, powering low-draw LED lights, running simple sensors, or small circuits. In parts of the world where electricity access is unreliable or expensive, small generators built from repurposed motors have genuinely helped people light a room or charge a basic device when they otherwise couldn't. This isn't a fantasy claim, it's a well-documented practical application of very basic physics using material that would have otherwise ended up in a landfill. There's also something deeper worth thinking about here, something that goes beyond electricity generation altogether. This entire idea challenges how quickly we decide something is worthless. A fan stops working, and within minutes, it's in a trash bag. Nobody stops to ask what's actually broken versus what's still functional. This happens with electronics, with appliances, with tools, over and over again, every single day, all around the world. And in almost every case, at least part of what's being thrown away still has genuine value, if only someone took a few extra minutes to actually look. That's really what this video is about at its core. Not just an old motor, but a different way of looking at things we've already decided are done before we've actually confirmed that they are. So now that we understand what's inside these motors, the copper, the magnets, the winding pattern, and why all of that matters, the next natural question is, what does it actually take to turn this into something usable? What tools do you need? What's the safest way to test one of these motors? And most importantly, how do you know if the one sitting in your garage right now is actually worth the effort? That's exactly where we're headed next, and trust me, the answer might be simpler than you think. Let's get into the practical side of this, because understanding the theory is one thing, but knowing what to actually do with it is where this gets genuinely useful. If you're standing in your garage right now, looking at an old dead fan, here's how you'd actually approach this in a real, honest way. First, you'd carefully remove the motor from the fan body, separating it from the blades, the plastic housing, and the switch assembly. Once you have the bare motor in your hands, you'd want to check if the shaft spins freely by hand. If it spins smoothly without grinding or resistance, that's a good early sign the internal parts, the bearings, the rotor, are still in decent physical condition. If it feels stiff or makes grinding noises, that usually means dust, rust, or old lubricant buildup, which in many cases can still be cleaned out, but it does affect how efficiently the motor will spin once you try to generate power from it. From there, the next step is understanding the wiring coming out of the motor. Most fan motors have a few wires, sometimes for different speed settings, sometimes just a simple 2-wire setup. This is where a basic multimeter becomes useful, not to overcomplicate things, but simply to measure resistance and figure out which wires are actually connected to the main winding. This isn't about guessing, it's about testing carefully, one step at a time, so you understand exactly what you're working with before making any assumptions about performance. This is also where patience matters more than excitement. Rushing this step is exactly how people end up disappointed. Not because the idea doesn't work, but because they skip the basic verification steps that actually make it work reliably. Once you understand the wiring, the real test comes next, spinning the shaft manually or with a small external force like a hand crank, a small pulley system, or even a bicycle wheel setup, and observing whether it generates a measurable voltage. This is the moment where the concept stops being theoretical and becomes something you can actually see and measure with your own hands. A small LED connected to the output wires, for example, can visually confirm that yes, this motor, the one that was headed for the trash, is now producing usable electrical output simply because you spun the shaft. It's a small moment, but it's a genuinely powerful one because it's proof, not a promise. Proof that something written off as garbage still had real function left inside it. Now, I want to be very clear about something, because this matters for anyone actually trying this at home. Safety and realistic expectations matter here. This is a low-voltage, small-scale project. It is not something that should be treated as a full home power solution, and anyone telling you otherwise online is exaggerating for views. What this actually represents is something smaller, but in many ways more meaningful, proof of a principle. Proof that the things we throw away without thinking often still have working parts inside them, parts that took real engineering, real copper, real magnets, and real manufacturing to create in the first place. Throwing that away without a second thought isn't just wasteful in an environmental sense, it's wasteful in a knowledge sense, too, because most people never even get the chance to understand what they had. Let's bring this back to the bigger picture, because that's really what this channel is about. We don't just look at objects, we look at the economics hiding inside them. And when you really break it down, an old fan motor is a perfect small example of a much larger pattern that plays out across entire industries. Electronics get replaced, not because every part inside them fails, but because one part fails. and replacing the whole unit is often cheaper and faster than diagnosing and fixing individual components. This is true for fans, for small appliances, for electronics of all kinds. The result is a constant stream of partially functional material ending up in landfills, material that still contains working motors, wiring, magnets, and components that had real value, if only someone had taken the time to look closer before throwing it away. This is not a call to become an expert electrician overnight. It's definitely not a suggestion that everyone needs to start dismantling every broken appliance they own. That's not realistic, and honestly, it's not the point. The real point, the thing worth remembering long after this video ends, is simpler than that. It's about a shift in perspective. The next time something breaks in your house, before you throw the entire thing away without a second thought, it's worth asking one simple question. What part of this is actually broken, and what part might still work? That single question, asked consistently over time, changes how you see the objects around you. It turns trash into unexplored potential, and that shift in thinking is worth far more than any single motor or any single project. Think about how many fan motors are sitting in landfills right now, all over the world. Motors that still have every single component intact, copper windings, working magnets, smooth spinning shafts, simply because the plastic blades cracked or a switch stopped working. Multiply that by every household, every apartment building, every office that's ever replaced an old fan instead of understanding what was actually broken inside it. That's not just wasted material, that's wasted knowledge, wasted potential, sitting quietly in landfills because almost nobody stopped to ask the right question at the right time. That's really the heart of everything we've talked about today. Not that everyone needs to go build a generator in their garage this weekend, but that everyone should start looking a little closer at the things they're about to throw away. Because, as we've seen today, sometimes the most overlooked, most ordinary object, a simple old fan motor, still has something real left to offer if you understand what you're actually looking at. Now here's what I want from you. If this video changed even slightly how you look at an old broken appliance sitting in your house right now, I want to hear about it. Drop a comment and tell me what old motor, old device, or old piece of electronics you're now looking at differently after watching this. I genuinely read these comments, and I want to know what's sitting in your garage or your closet right now that you might have written off too quickly. And if you know someone, a friend, a family member, anyone who's about to throw away an old fan or an old appliance without a second thought, do them a favor and share this video with them before that motor ends up in the trash for good. Every share helps this channel keep making videos like this, videos that dig into the economics hiding in plain sight all around us. So drop your comment below, share this with someone who needs to see it, and I'll see you in the next one.